Welcome you all for another beautiful presentation on network analysis. Sometimes this subject is also called as circuit theory or circuit analysis or otherwise network analysis. So this is another very important subject as far as the GATE examination as well as the UPSC IAS examination is concerned, right? So the network analysis is basically it, it is a subject which gives us the flow of current throughout the given circuit, right? So we will estimate what is the amount of current flowing through the circuit. That is very important primary parameter that is to be obtained. So any physical system or any system is represented in terms of the circuit. That is why, and we will analyze the circuit by estimating the flow of current within that circuit. Is it not? That is why the circuit, that is why the subject is called as network analysis. We will analyze the given network or the circuit, network also called as the circuit, in which the flow of current will be estimated. That is the main purpose of this subject actually, right? So what are the primary things, or simply in otherwise, what is a circuit actually? Circuit is nothing but it is an electrical circuit consisting of various electrical parameters, right? So network is also called as, it is a circuit basically. It is nothing but a circuit, or simply also called as your network. So what is a circuit or what is a network? It is nothing but it is a circuit or electrical circuit consisting of various electrical parameters. So it will have different electrical elements. Otherwise it will consist of various electrical elements, namely the resistance R, and then capacitance C, and then inductance L, and sometimes we will measure what is the voltage across certain, I mean the electrical parameters or capacitance C or L, or sometimes we will find out the current also. So these are the various electrical elements that are need to be associated with that given electrical circuit actually, right? So therefore in brief, otherwise I will tell you in brief I will explain you one simple circuit actually for your understanding of a circuit. Let us say, for example, here I am drawing a circuit diagram which is having a simply resistances, right? So for this I am giving some voltage here, and I am closing this circuit like this, right? So here this is plus, obviously this is minus, some voltage source I am connecting here, voltage V. I am calling it as resistance R1, and this is I am calling as resistor R2, and then this I am calling as resistance R3. This particular circuit is called a simple electrical circuit, which is consisting of only resistances, various resistances like R1, R2, R3 with one voltage source, right? This is a simple electrical circuit actually, right? So we need to estimate this circuit, or we need to analyze this particular circuit. What is the analyzation, or what is the analysis? Analysis is nothing but finding the currents within the circuit actually. What is the current flowing through the circuit, and what are the voltage drop across each element or resistive element, that we need to find out. That is what the analyzation meaning actually, is it not? Therefore, so this is the simple circuit, this is a simple electrical circuit consisting only simple element which is resistance, right? This is what, for example, I am explaining you, right? And therefore now So this is the simple resistive network actually. This is the simple resistive network. Or sometimes in the given circuit you can use the capacitances also, right? And basically let us see what are the basic elements. As you all know that what are the basic electrical, what are the basic electrical elements, what are the basic electrical elements. Just now, as I have already told you just now, those are, the first one is resistance. What is that? The first one is resistance R, and the second one is capacitance. Is it not? The second one is capacitance, denoted by C, and the third one is inductance. The third one is inductance, denoted by L. These are the primary electrical parameters that are need to be used in any electrical circuit actually. Most of the electrical circuit consists of these elements only. Is it not? And afterwards, if you see how these elements will be taken or how these elements will be connected. So the resistances can be connected either in series, or otherwise the resistance can be connected into parallel also. Similarly, the capacitances also can be connected in series or otherwise in parallel. Similarly, the inductances also can be connected in series or parallel, like that, as per the application of the circuit, right? So anyhow, these are the primary electrical parameters most of the time which we will have in any given electrical circuit. Is it not? Normally the resistance is measured in terms of ohms, that is denoted by the symbol like this. This is called ohm. Simply you can write OHM, ohm. This is the representation of that. Okay, ohm, right? Capacitance is measured in farads. Okay, farads. Okay, farads, or simply you can write like this, F, farads. Similarly, the inductance is called in henries. This is measured in terms of henries, H. Right? These are the units of the electrical parameters. So the unit of resistance is ohm, means that the resistance is measured in terms of ohms, and the capacitances is measured in the farads. Okay, our inductances are measured in terms of henries. Clear? So likewise, and similarly let us see about the basic information about these resistances. So how the resistances can be connected in any given electrical circuit. The possibility of the connection of given resistance actually. The resistances, okay, let us say for example about the resistance. The resistance, if you see, actually what is the resistance? What is the resistance? Resistance, as the name itself implies, is that it resists the flow of current. It resists the flow of current. That is what it opposes basically, or sometimes this is also called as current limiting resistor, or otherwise this is also called as current limiting. It limits the current actually. Current limiting or current limiting element. This is also called as current limiting element. That's why in most of the electrical circuit, if you see practically, so the voltage will not be connected directly to any other other system or other element directly. So the voltage must be connected through resistor only. So there is a resistance between other elements to the voltage. So the intermediate must be a resistance. Why resistance is used? Because it limits the current. It resists the flow of current, means the excess flow of current will be limited by the resistance. That is why it is a very useful electrical parameter in electrical circuit. is it not? That is what the main purpose of a resistor. So resistance is called a current limiting element, is it not? So how these resistances can be connected? What are the combinations available? So as you already know that, so these resistances in any given electrical circuit can be connected into two possible bases. Those are called, one is a series connection. What is that? One is series connection and the second one is the parallel connection. One is the series connection and second one is the parallel connection, right? One is the series connection. So means that what, in series connection the resistance, as I already, so the resistances is denoted by the symbol like this. This is the simply representation of a resistor R. Let us say there are two resistors, there are two resistances R1 and R2. Let us call it as R1 and this is called R2. If these two resistances are connected in series, as I have mentioned here in the first case, series connection, so it is very simple actually. Means that, so both resistor, these resistors will be connected like this. Means the first resistor and the second resistor is also connected in this way, exactly like this, and across these two some voltage will be connected. Some voltage will be connected. Let us say, forget about the voltage source right now, and the connection, you just focus on the connection. Therefore, so if R1 and R2 connected in this way, in this fashion, this is the R1 actually and this is the R2 and these two are connected like this is called a series connection. This is called your series connection. So in the series connection the equivalent resistance can be given as equivalent, that is denoted by R suffix equivalent. R equivalent is equal to, it is simply sum of the both resistances R1 plus R2. That's it. That's it. That is R equivalent, R1 plus R2. Let us say it is 5 ohms. Let us say the R1 value is 5 ohms and R2 is something 10 ohms, let us say. Then what is R equivalent? R equivalent is nothing but sum, means both will be added. Means it is 5 plus 10. It is nothing but 5 plus 10 ohms. It is something 15 ohms. That's it. That is the series connection. Whereas, so here one important thing that I would like to explain you is that if these two are connected like this in this way, across some voltage source V, and definitely whenever we connect these two resistors in such a way that because of this voltage source some current I flows through the circuit, I will flows through the circuit, right? So in this case, in this series connection, whatever the current generated by this voltage source in this circuit, the same current flows through both the resistances actually. The same current flows through. Whenever the resistances value may be differ, means the resistances value may be different values. As I have already indicated here, it is a 5 ohm, it is a 10 ohm, both are different values, but same current flows through the both the resistances. So that is very important to note down. So when the resistances are in series connection, same amount of current flows through these resistances, same amount of current, but if you see the voltage drops across each resistor. Voltage drop. What is the voltage drop? Let me explain you that also. What is the voltage drop? Voltage drop is nothing but the voltage available across each resistor. So for that I need to explain you, that is the Ohm's law. Very important law. Quite Ohm's law. Quite oftenly we will use this law in this electrical circuit. Ohm's law. Very important. Very important law, Ohm's law. What is the Ohm's law? You know, Ohm's law states that any resistance is connected across some voltage source V. Clear? Any resistor, some R, is connected across some voltage source V, then some current I will flows through the particular. It is a circuit now. It is a simple circuit actually. Okay, this is the voltage source we have connected here. Okay, so this is connected in this fashion. It is a simple, very simplest of the simple electrical circuit. It is a network, or otherwise it is a circuit actually. Clear? Now here if you see that in this case your voltage is proportional to V is proportional to I in this case, right? The applied voltage is proportional to the current flowing through that circuit, that is V proportional to I. Clear? Means that what, if the voltage increases, right, correspondingly the current flows through the circuit is also increases. That's what. If the voltage decreases, then automatically the current flowing through the circuit is also decreases. That is called directly proportional. Both voltage and current are indirectly proportional. Okay, that is what. So according to Ohm's law, the voltage is directly proportional to I. V is proportional to I. Okay, then if you remove this proportionality, then you can write that V is equal to some constant I have to introduce. That constant I am calling as R into I. Clear? So if I remove this proportionality, then I should insert a proportionality constant, that is what resistance R. Where R is actually proportional constant. That constant I am calling as resistance in this case. That is what. Therefore now V is equal to I into R. This is the famous equation named as Ohm's law. This is called as Ohm's law. By the way, this much voltage appears across the resistor element R. Means that what, this is the resistance. Across this resistor, the voltage V will be appeared, and this V is equal to I into R. Means that what, it is product of or multiplication of the current flowing through the circuit multiplied the resistance value. The current flowing through the circuit I multiplied with the resistance R, I into R. That gives the voltage. That much voltage appears across the resistance. Clear? That is what the Ohm's law actually. That is what the Ohm's law. Therefore, simply remember that V is equal to R into I, volts, and its units are volts, right? So that is measured in terms of volts. Therefore, according to this Ohm's law, if you see that, yes, in this circuit which we have considered now, these are the two resistors. Obviously, across this R1 we will have certain voltage source. No, let us call it as V1. Let us call V1 is the voltage drop across the resistor R1, and let us say across R2, let us say that V2 is the voltage drop across R2. Clear? Now if you sum these two, means if you add these two, V1 plus V2, definitely V1 plus V2 is equal to your V. Therefore V is equal to V1 plus V2. The sum of voltage drops must be equal to the input voltage source. This is what your KVL actually. In next presentation, I will explain you what is KVL, which is called Kirchhoff voltage law. It is called as Kirchhoff voltage law. What is Kirchhoff voltage law? The voltage sources, the sum of the voltages around a closed loop must be equal to 0. Must be equal to 0. Okay, so nothing but this only. So V is equal to V1 plus V2. Clear? So means that what? So V1 is the voltage drop across R1, V2 is the voltage drop across R2. If you can observe that, so here what is the V1? It is I into R1. What is here V2? I into R2. Understood? So V1 is, what is V1 here? V1 is equal to, from this expression, what is V1? V1 is nothing but I into R1 as per your Ohm's law. I into R1. And what is your V2? V2 is equal to what? V2 is equal to I into R2. I into R2. So the same current flows, but the values are differs. R1, R2 are differs because it is 5 ohms than 10 ohms. So means that what actually? So across the both resistor, the voltage will be different. The voltage will be different. So the voltage drop will be different. So it could be some value, V2 may be some different value, but the current will be remains the same. So same current flows through the circuit, but the voltage, if you consider the voltage will be different in the series connection. I hope you understood well this concept. I think I will finish off this presentation here. Clear? Just very simple circuit we have considered. It is an example of, okay, I mean series connection of the resistances. In the series connection, how the current will flow, and similarly we have seen how the voltage drop will be across these two resistors that I have explained, right? So I think you have understood well, and with this I finish off this presentation here, and subsequently we will continue the extension of this presentation in the subsequent presentation. I hope, right, you understood well, and if so, definitely don't forget to share with your friends, and then, okay, and give your observations and comments, so that it will be very much useful for incorporating in the subsequent videos, and thereby uh, it will be good for us to, improve the content of this presentation, right? So have a good day.